Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Hello and welcome to another episode of the Chai Time Data Science Show. In this episode, I interview Navdeep Gill, Senior Data Scientist and Software Engineer at H2O.ai. In this interview, we talk all about the intersection of these two fields, data science and software engineering, best practices for both data science and software engineering, and how much of software engineering skills should a data scientist really know is the question that we also discuss in this interview. We talk all about Navdeep's journey into machine learning interpretability, and his journey at H2O.ai. We also talk a lot about machine learning interpretability, Navdeep's thoughts on it, as well as MLI inside of H2O's products. Quick reminder to the non-native English-speaking audience, please remember to enable the subtitles on YouTube or watch the interview on YouTube instead of listening. Yes, the interviews are available in video and audio formats, because the subtitles have been manually re-uploaded and term checked for corrections. Without further ado, here's my interview with Navdeep Gill, all about machine learning interpretability, software engineering, and data science. Please enjoy the show. Hi everyone, I am really excited to have another, if I may, great maker on the show. Navdeep, thank you so much for joining me on the Chai Time Data Science podcast.
Yeah, no problem. It's an honor to be here.
Likewise, it's great to be finally talking to you on the show. So I want to start by talking about your background. You studied stats and psychology during your bachelor's days. Was that your secret preparation towards machine learning? How did the dots connect for you? When did you get interested in machine learning over the years?
Well, yeah. So when I started off college, I was initially just majoring in psychology, and I was also studying mathematics at the time. And I thought, well, I was really interested in how the mind works. I was interested in all of these things I've learned about in high school when I took like physiology, and I learned about the brain and all these type of things. So I thought, well, maybe I can make a career out of it. So initially, psychology was sort of the degree that stood out to me. And then plus taking classes on, certain biology and chemistry and mathematics, all that kind of pieced together, I thought it would give me a better understanding of the mind. I thought I would maybe go into clinical psychology, maybe be a clinical psychologist working more on the experimental side. So not really the side that speaks with clients per se, but the side that runs experiments, tries to understand how the human mind works in certain aspects, whether it be vision, hearing, cognition, all these type of things. So that's where I initially got started. And then I started working in a lab at my university, and a lot of my work was pretty much data analysis. That's pretty much what I was doing. I mean, yeah, we would formulate problems, we would write papers and all these type of things, but a lot of my time was spent behind a computer, just analyzing data, using languages like Python or R. Back then we used SPSS, so then that was sort of this GUI interface, kind of like RapidMiner or something like that, those type of tools. So I was spending a lot of time analyzing data. And then my advisor at the time suggested that I also study statistics, because I was planning on going to graduate school, like a PhD program. And he suggested to study stats because it sort of gives you the technical background and sort of an edge over other applicants who probably do not have that background, or maybe only have 1 or 2 stats courses. And at the time, my university offered a pretty good program in which statistics could be double majored with a lot of other majors, because they allowed a lot of courses to overlap with each other. So I just decided to pick up another major in statistics. So then I got my bachelor's in stats, my bachelor's in psych, and I minored in math, all in college. And I thought that was a pretty good package to have going into a PhD program. I thought it would give me sort of an edge over other applicants. So I went down that route
Okay.
initially. Yeah.
Were you always drawn to programming and maths? Because that's something that if I think usually biologists or even psychologists are slightly distant from. Were you attracted to that?
Yeah, I think I've been attracted to programming ever since I was a little kid. My dad taught me BASIC when I was younger on my little MS-DOS computer back in like the mid 90s, early 90s. So I've always been attracted to that. And then, both my parents, they studied, they sort of have scientific backgrounds. My dad studied chemistry, my mom studied economics. So, growing up like that, you sort of get attracted to science, you get attracted to building things.
Yeah.
I had like a little chemistry set that my dad got me when I was a kid. I had a microscope and all these type of things. So I think all that mixed together, I sort of got into programming through my father, and then the scientific side sort of picked up from both my parents, and then I have other relatives who are in the science field. So it's just been sort of part of my life for a really long time. So I think it's just something that just happened. I don't know. I don't think I ventured out and looked for it. It's just something that just happened to me, and I just happened to enjoy it.
Okay. And talking of science, you also worked as a research, I think, contributor during your undergrad days in research labs, and you were way ahead of the curve. You were already interested in 3D perception problems. You were working on problems that were even not highlighted before the AlexNet boom. Can you tell us more about your research ideas and experiments from your college days?
Yeah, sure. So, I worked in a few labs. Just all that getting, I thought I would go to a PhD program. So, one of the pieces of advice that I got was, you can take all the courses you want, you can get the good grades, but it's really good if you can get a couple publications out there. That sort of that sort of showcases your skill set a little better than, let's say, an A in some mathematics course or psychology course or something like that. So I initially just started reaching out to different labs saying, I can come in a couple times a week. You don't have to pay me. I'll just show up and I'll just do work with you. And then we can write on a paper. Or we can, I can just put something on my resume that shows I learned some new skill and, this is something I can potentially apply in a future graduate program. So the simplest lab to join first was the lab just that my advisor ran. And he ran a lab that had to do with measuring human attention. So it was a lot of behavioral experiments that we did. So this involved a lot of MATLAB programming, which sort of helps design the experiment, make the experiment. Because a lot of times when you do attention experiments in psychology, it just involves the participants doing some task on a computer. And that task has to be programmed. So then sort of that was my responsibility of the lab is to put these tasks together, make sure they run accordingly, they collect the results efficiently, they produce the results in a well-equipped manner, and then I analyze the data, and then we would work on some manuscript together. So that's sort of where I started with those. And a lot of the research ideas was sort of stuff that my advisor worked on during his PhD, and we sort of branched off from that. So we would look at things like, what happens to human attention when they get distracted. So this was during the time when California was trying to pass a law about not using cell phones while driving cars. So now it's sort of a norm across the United States. Back then, it was still being debated. So then, there were people at places like the University of Utah who were analyzing this type of thing, and we were analyzing it too. And basically, it's what you would expect. If you are distracted when doing some task, your performance degrades on that task. So we just had a simple task. No one's life was on the line, of course. But if imagine driving a car and you're distracted, that can cause a lot of damage to a lot of people.
Yeah.
So we were able to showcase this through different conference presentations, things like that. And that was sort of my first glimpse into doing some type of research. And then, so at the time I thought I would go into maybe clinical psychology. At that point in time, I decided to maybe shift to cognitive psychology, more of a experimental psychology, which is sort of so in that field, that's where stats, math, and like statistics sort of overlap with each other because you're doing a lot of data analysis, a lot of experimental design, which is key in statistics. So that's sort of how I got into that path. And then based off from there, I started working in other labs as well, like at UCSF. I started working at Smith Kettlewell Eye Research Institute. And at those two places, I picked up skills in MRI imaging and electrophysiological experiments. So you can see I was just trying to get my hands dirty in a lot of different aspects of neuroscience, and I was trying
Yeah.
to learn as much as I could. And I have my advisor to thank for that, because he said, you're at a point where, you're pretty young and you can just try a bunch of different things, and it's not a big deal if something fails, because if it failed, it's okay. You haven't invested in a PhD program of any kind. You need to sort of go out there and understand what you like, what you don't like, and based off of that, you can sort of apply to the programs you like. Because when you apply to these PhD programs, which I thought of applying at the time, it's not really about the university or anything like that. It's just about the problem you're going to tackle in graduate school and who you will work with. It doesn't matter where they are. And that's sort of the key piece of information I got from doing that. So yeah, based off of that, I was able to pick up a lot of different skills, and that sort of led me to um, figuring out what I was interested in. And at the time, doing all this, I sort of fell into having interest in attention, human attention, cognition, vision type research, and across all this type of research, one thing that always comes up is aging. So one thing I sort of got into when I was at UCSF is they did a lot of research. The lab I worked for did a lot of research about aging and what happens to your cognitive abilities with aging, and what can we do to improve these cognitive deficits that happen with aging. Yeah.
Okay. I think many people miss out on this point that your passion should really be curiosity driven and not market driven. You shouldn't go out and see, hey, data science jobs are paying much higher. Should I just go out and chase that? Who knows by the time you're an expert if that'll be true or not, or if you'll even enjoy it.
Yeah, I agree. I think definitely curiosity sparks a lot of passion in a lot of people's lives, and I think that's what people should really aim for when it comes to what their interests are. The cool thing about data science is you can say I want to do data science and apply to many different fields. So you
Yeah.
can have an interest in, let's say, I don't know, medicine or biology, bioinformatics, chemistry. All that stuff involves analyzing data, and all of those fields involve um, designing certain or framing certain questions, which is what data science is really about. Um, you know, that's what statistics is about. So, John Tukey says the, famous quote, the great thing about stats is I get to play in everyone's backyard. So I think that's the beauty of data science as well, is you get to sort of take the analytical skills you have and apply to some passion you're interested in based off of some curiosity you have. And I think that's sort of the key takeaway, I think, with how you should pursue certain things in life.
Definitely. How do you feel about the fact that when you were working on research problems that were unsolved at the time, for example, right now we don't even have computer vision yet in driverless AI, it'll be out soon, but whatever problems you were working on back in the day can now just be solved with a click launch experiment. And back in the day, those were unsolved. How do you feel about that?
I think I think they're solved in the sense of doing the task itself. So we don't have to, let's say, program like some neural network all the time, or some GBM model all the time, or some decision tree all the time. But I think the thing that keeps science going now is all of these tools enable people to tackle a lot of different problems. And it sort of lets, uh, whether it be scientists or people working in, law or anything like that, it sort of lets them think about the problems a lot more, maybe come up with more questions to ask, instead of, spending more time on just performing some mundane task, whether it be, just tuning parameters or anything like that. I mean,
Yeah.
it could be interesting, but at the same time, it could be pretty mundane if you'd rather just be thinking about, the proper question to ask. So I think a lot of these tools, these analytical tools we have now, like Driverless AI and like all these AutoML type tools, they sort of enable people to ask more questions and enables them to experiment a lot faster. And then based off of that, you can sort of solve problems better. You can probably fail quicker and figure out what to do next. Um, the thing I noticed was when I was in neuroscience or psychology, is I was spending a lot of time, designing experiments and then putting a lot of stuff together. But the real work is done figuring out before you start anything, is it even worth investing in? So with these data science tools that are coming out, I think you're able to figure out a lot quicker if it's worth the time to invest in a certain problem. And you might find out quickly that maybe your data set is just not well equipped for this, but you can find it out in a fast manner and then sort of make the proper steps to fix that. So I think that's sort of the benefit of these analytical tools coming out nowadays, specifically like driverless AI and those type of tools.
Coming to where you're contributing to help humans answer the bigger questions, can you tell us more about your current day? Like, what does a day in your life currently look like, and what problems are you working on at H2O.ai?
Yeah, so currently I'm working with the learning interpretability team, H2O. So we offer MLI as the acronym we use, and we offer that through Driverless AI. So it's a way to sort of interpret, explain your model, debug your model. So these are the things I'm working on nowadays. Is sort of thinking of what type of applications or algorithms we can apply to sort of dive into the model itself and sort of piece out information that we need from the model to understand if it's doing what we expect. So, day to day, I could be, most of the time, I'm like usually programming something into the MLI module that we offer in Driverless AI. There's obviously, sort of like a software engineer, you're still doing, bug fixes, testing, all these type of things. Um, my colleague Patrick Hall and I, we work on a lot of different blogs together, a lot of papers we've been working on recently, booklets, things like that. So that's sort of my day to day is, sort of road mapping what we think we should work on, and then, just working on it throughout the day. Yeah.
Okay. Can you tell us more about machine learning interpretability? Why is getting SOTA accuracy not good enough? Why do you need to interpret models? Where is it required and important?
Yeah. So I think when it comes to machine learning itself, yeah, you can build out a great model that's pretty accurate, but that model itself is inherently biased. There's certain biases that are in that model itself, and you sort of need to uncover those in sort of these applications, specifically high stake applications. And by high stake, I mean things like, if it has to do with medical diagnosis or it has to do with fraudulent activity, you're trying to predict some type of fraud, or you're trying to predict if someone should get a loan for a home, or someone should be denied credit or accepted for credit for a certain credit card or loan application. I think with these, it involves a little more due diligence from the data scientist or from the analyst or business stakeholder at that point. It's not enough to just build a model and, take it, as it is and accept it for what it's doing and basically trust it. I think when anyone's building a machine learning model, you should have some doubt when you build that model. And you should try to take your domain expertise or someone else's domain expertise. Maybe they know more than you, or which is usually the case in a lot of big organizations. You sort of want to take that into heart when you build these models and make sure that the results you're seeing actually do make sense. You do need to do the due diligence of exploratory data analysis and then post hoc analysis of the model to see what the model deems important and what you think the model should deem as important. And you sort of want to go from a global level of looking at what the model does globally, and you want to look at what it does for certain groups of observations. Now, these observations can be people or anything like that, but you want to see that the model is sort of looking at everything in a uniform manner. And if it's not, you want to understand why it's not looking at everything in a uniform manner. Why is it treating these groups of people differently than these groups of people, this specific row versus the entire data set? This involves a lot of work, I think, from the data scientists still. And I think you can try to automate the process itself, but at the end of the day, you need a human in the loop to sort of look at everything. And then, so it's not enough just to look at accuracy. I think accuracy is probably like step zero. Like you're just looking at, is this model even good at classifying something for me?
Yeah.
Okay, it's good at classifying something, but does it make sense? Is it picking out is there some leakage that I'm not seeing and it's not making any sense? Or is it picking out variables that are important that shouldn't be? So I think sort of that's where MLI comes into play. Is it's sort of this process of doing machine learning in a responsible manner, especially when it comes to high stake applications. You really want to make sure that what you're deploying is fair. What you're deploying is not biased towards anyone, because if it is, you're going to run into a lot of issues for yourself, for whatever team you're working on, and maybe for even your organization. So
Yeah.
I would think that's where MLI comes into play for sure.
We've already seen such issues already recently coming up in the news where banks have had issues of the processes that they automated using machine learning. Where do you think MLI comes into the picture of AutoML? Because AutoML essentially aims to replace the complete human in the loop. Where would MLI
Yeah.
come in that picture?
Yeah, I think MLI is, it's going to be, sort of the last step you do before you decide to deploy something. I think AutoML, with tools like Driverless AI, and then, I think Google has tools coming out and things like that. I think those tools sort of are doing a pretty good job at automating the model building process. So before grid searches and things like that, people were just sort of tuning models and then trying to figure out how to make this model pretty accurate. And
Yeah.
that took a lot of time. I remember before being introduced to grid searches, you would spend a lot of time just trying to tune a model and figure out, what parameters you should use, cross-fold validation, all these type of things. But a lot of that stuff is automated now, especially with tools like Driverless AI. So with AutoML, I think it allows people to experiment more, build more models in an efficient manner. And then that allows them to spend more time on debugging the model, explaining the model, figuring out what the model thinks is important, and and looking at the stability of the model per features, like partial dependence, things like that. I think spending more time on that is what AutoML enables. It enables people to sort of critique the model a lot more. In the past, if you spent a lot of time tuning the model and then you spend a lot of time debugging the model, explaining the model, that whole process could, really hinder a project. But nowadays, I think with AutoML, you can do the modeling aspect pretty quickly, and that sort of diminishes the time it takes to tackle a data science problem. So you can spend more time, in the pre-processing of the data, exploring the data. And then once your data is, set, you can just churn out many experiments with a tool like Driverless AI, for example. And then you can spend a lot of time trying to explain that model and see if it makes sense to you. And then, that loop is sort of getting quicker for people, I think, with AutoML tools. So I think where MLI comes in, it just comes in as another step that people can spend more time on now. Instead of
Yeah.
glossing over, the feature importance or local feature importance, or, sort of the reasons behind why a model made a decision, you can spend a lot more time on it. You can critique it a lot harder. And I think that just makes for good science in general.
Like you said, it'll allow us to look at the bigger questions and have the automated process already being handled.
Yeah, exactly. Exactly. I think it just allows people to experiment more, formulate better questions. It's called data science, and science is in the title. So I think
Yeah.
with AutoML tools, we should let data scientists focus on the science, focus on making better questions, focus on collecting better data. Those type of things are what data should be focusing on, and the model tuning should be. It has been shown to be automated, and then we should take advantage of that, and we should model or build as many models as possible, and then try to debug all of them, and then based off that you can pick the best one that you think is, whether you could think it's fair and accurate. So I think that's where we're heading at this point.
Definitely. So you mentioned a bunch of ideas or open research questions that are present for MLI. Can you tell us what all are already being handled or have been solved inside of H2O products, and what can we currently do using any of the H2O products?
Yeah, so with the MLI module today, like offered through Driverless AI, you can do a lot of different things. So, globally, you can get things like feature importances. You can look at Shapley values, which is a more accurate way of looking at feature importances. You can look at things from a local perspective. So this is looking at clusters of data versus rows of data versus the entire data set. You can do sensitivity analysis in MLI today. So, that's a pretty powerful tool that basically involves, perturbing some row of data or collection of data and seeing how the model actually responds to that. So that goes back to what I was talking about earlier about having some stability in your model. You want to see, when does your model really break down? And that's where sensitivity analysis comes in. It's a topic that's been used in a lot of engineering fields. You can simply apply it to a model. So in engineering or chemistry, there's like these physical models and you want to see how they perform. Well, now we have a machine learning model. You can do the same thing. You just take the data, change something and see what the model does and how
Yeah.
stable it is. And then we offer things like disparate impact analysis, which is a thing used in a lot of regulated industries. And that basically involves looking at certain metrics like true positive rate, true negative rate, false positive rate, et cetera, across different demographic groups. So let's say you built a model that's predicting whether someone should get a loan or not. And in the model, if you're in a regulated industry, obviously you did not use demographic variables in your model. It's just not allowed. So you can't use something like gender or race or anything like that. But the problem is those variables can be correlated to certain things. So in doing disparate impact analysis, you can sort of look at your model post hoc and see, is there any significant differences in these metrics like true positive rate, or a false negative rate across, let's say, gender. And if there is, you can sort of, detect that quickly, and you can sort of remedy that. Um, in MLI, we also offer things like Lime. So, but we call it K-Lime because it's a faster implementation. This involves, you have your complex model. Your complex model has the Y hat or the predictions, and we can build simpler models, which are called surrogate models, to that complex model's predictions. So you can build a global, let's say, GLM to the predictions of your complex model. And in K-Lime, the stands for the K-means process. So you can cluster the data based off of K-means, and then you can build subsequent GLMs for each cluster. And then based off of that, you have reason codes, because GLMs give you coefficients. It's a linear model. So you can look at the reason codes, and you can be confident that, if I take this beta times this value for my row plus, the rest of the betas times the rest of the values for the row, I can get what the GLM predicted, and then you can get your predictions that way. So it's a way of coming up with these reason codes. And the reason codes are something from regulated industry, specifically banking. And then basically what that has to do with is, if you're denied credit, for example, in the United States, the bank sort of has to tell you why you were denied credit. So these are called reason codes for your denial. And it could be things like, you've defaulted on a lot of payments in the past, I don't know, 2-3 months. So in MLI, we can give you these type of reason codes for any type of model. It doesn't have to be specifically banking. We just call them reason codes because they're the reason or potential reasons why the prediction was the way it was. So we offer that today through Driverless AI, and then we also offer other surrogate models. Basically, it's the same concept. You're building a simpler model to the predictions of your complex model, and you're trying to explain what the model's doing. So this is a pretty powerful tool when it looks at when you try to see if other models can sort of try to understand what your model's doing, and it sort of helps sort of debug a little bit more. Because as we know, there's like the data set you used to model your problem that sort of gives some, it's not really reality, it's just a sample of reality. And then your model is taking that sample and it's building its own reality and what it thinks is going on. So where the surrogate model comes in is it's trying to dive into what's the reality of your complex model that you want to deploy. What does this model think? What sort of features does it think are important? These type of things. And the simpler model sort of helps humans understand it a little better. So I think we offer a variety of tools today through MLI that we've worked on for the past few years. I think it's one of the few commercial tools that are offered today. So, it's pretty nice that no one has to sort of import a Python library and try to do it themselves. It's sort of out of the box if you have Driverless AI.
Yeah. So you mentioned the ideas that have been solved, but there's now this push towards having more complex models. We have transformers in NLP, for example, and there's this also push for interpretability. What's your take on that? How interpretable will models be as they continue getting more complex with more compute power pouring in?
I think a lot of people are going to sort of figure out that they need to have more interpretable models in the future. People have already started building out interpretable models today, and what we're starting to see is so for a long time people thought there was a trade-off between accuracy and interpretability, but what we're starting to see is that's not really the case anymore. So there's a lot of interpretable models out there that people can use. There's models coming from Cynthia Rudin's group in Duke, Rich Karuna in Microsoft. He works on a lot of interpretable models, and I think that's what people are going to start to notice is key, especially in regulated industries, where people do want the accurate models, but they probably stick with GLMs or interpretable GBMs like monotonic GBMs because it's sort of the safer way to go about things. You sort of avoid not being able to interpret a model and using a model like that. So I think that's where people are going towards right now. Even if you build a complex model, people are still trying to build tools that can explain these complex models. So a lot of people are building on tools that can explain deep neural networks. People are working on tools that can explain certain NLP models. So, I think like every other week, I see a new NLP architecture or something like that. But, those architectures need to be explained. And I think in tandem, people are working on those both. For example, Samir Singh at UC Irvine, he works a lot on NLP, and he works a lot on MLI, and especially how it's applied to NLP type models. So I think groups like that, like Samir Singh's group, there's groups up at the University of Washington. Like I think um, they're sort of seeing what a lot of other people will potentially see, is that you can build out these complex models, but you need to understand them, especially if they're going to be used in a lot of applications that have, that affect a lot of people. I think they should really take a look at it, and I think they will. I think people will understand that.
Mhm. Now, many of the audience might be feeling intimidated by all of this conversation. I want to mention a resource that has been authored by you, a book to introduction on interpretability. It's for free, so you can find the link in the description if you want to go ahead and check it out. Why did you decide to author the book? Were there any other resources? What led you to? Because writing a book takes a lot of efforts. Why did you do it?
Yeah. So at the time, MLI was not being worked on at H2O when we first wrote the booklet. So Patrick Hall is the main author, and I co-authored with him on the booklet. And when he joined H2O, one of the first things he was working on was machine learning interpretability. And I remember at the time, this was a few years ago, we didn't really have driverless AI at the time, or
Yeah.
it was just starting out. And I was pretty intrigued by MLI. I didn't know too much about it at the time. I knew certain methods, but just not all the methods that were coming out in the literature. So I knew certain things like, there's PDP, so partial dependency, ICE, feature importances, all those type of generic things that we've seen. But, at the time, papers like the Lime paper came out, so that was a big deal. So I was pretty intrigued when Patrick was sort of building out this team, and I was asked if I would, sort of join or help out, and I agreed. I wanted to. I was interested. So we started working on MLI together. Initially, we thought it might go into H2O3, and then we, thought, well, maybe it'll go into driverless AI. So we decided to just go down that route. And then one of the first things we were doing is, um, you know, uh, writing about MLI. And then Patrick had a few articles on O'Reilly about MLI. And then he was offered a chance to write a booklet. And he asked if anyone would like to co-author. And at the time, I thought, well, I think this would be interesting because I think this would be a good way to learn about MLI, because it would involve doing a lot of research, reading a lot of papers. So I thought it would be beneficial to myself to do something like this. And also getting a booklet out there is pretty interesting to see if anyone would read it. I didn't know if anyone would be interested, but I'm glad the turnout has been great. So that was sort of my reasoning behind doing this booklet. Is I thought it would just be a great learning experience for myself, sort of force myself to read the literature, look into the tools that are available today. And from an engineering standpoint, it was sort of like this competitive analysis, like what's out there and what can we use and what should we build to into our tool itself to sort of enable customers.
Okay. Now, coming back to your work and your journey at S2, you joined, I think, around I think 4 years ago. How has your work evolved over the years? Even Driverless AI, our flagship product, didn't exist back then. What problems were you working on, and how has your work evolved over these years?
Yeah. So when I first joined H2O, it was sort of the end of 2015. It seems like ages ago. That's when I joined, and back then we obviously had H2O3, which is the open source software, and we had Sparkling Water, which is embedding H2O3 in Spark. And at the time, we were also coming out with Steam, but that was sort of in its infancy at the time, if I remember correctly. And back then, what I mainly worked on was, I was hired as sort of this, I think my title at the time was like hacker scientist or something like that. And I was basically working a lot on sort of data science problems with customers. And I was also working a lot on quality engineering. So, a lot of testing was happening back then, and I was sort of helping out with that with the rest of the team. And I was also working on H2O3, so the core platform. I worked on that for a couple of years in the beginning. So this involved things like implementing new data science methods per se, mainly like exploratory data analysis type methods, and involved adding minor features to certain models that we offered, bug fixes, testing, lots of testing, presenting at conferences, building out packages. So like, one of the packages I worked on was R Sparkling, which was adding, sparkling waters, R API, things like that. So it was a lot of working on open source, a lot of the open source tools at the time I was working on. And this was before, obviously before Driverless AI came out. But back then our flagship product was H2O3. And that's what we offered to a lot of people. And that's what mainly everyone worked on. At the time, I think the team was mostly engineers. Now it's sort of a big mix of sales, marketing, and engineers. But at the time, it was just a group of engineers in the Mountain View office, and we were all basically working on either H2O3 or sparkling water or a little bit of both.
Mm-hmm.
And that's what I mainly worked on back then, and that's what mainly everyone worked on back then, to be honest.
You've also been a big supporter of open source over these years. Can you tell us about your open source journey? And beginners usually feel very intimidated about contributing to open source because you come and there's this huge repository of wonderful code that's been written by someone. What advices would you have for them?
Yeah. So with open source H2O3 specifically, I got introduced to H2O3 because of open source, and that's sort of how I got into it. So at the time, I was working at Cisco at the time, and I wanted to use some machine learning library that was pretty powerful. So I decided to use H2O3.
Okay.
And then I realized, it's open source. That's pretty interesting. I never thought about that before. That it's sort of this. I mean, I have seen open source machine learning libraries, but not ones run by a company per se. So like at the time, it was like scikit-learn, XGBoost, all these type of things were run by a group of people from like a academic background or at like a university. And then here's H2O3, which is backed by a company, and it's completely free. And that's sort of where I got intrigued by open source software per se. I thought, it's a pretty powerful idea to sort of open up your software, let the community contribute, let the community use it for free, and sort of use that to enable improvements to your product itself. So that's how I sort of got interested in open source. And I think your second question was about, if people are intimidated by contributing to a project or anything like that. A lot of the good projects are pretty good at having issues open that are meant for newcomers. Mm-hmm. So my suggestion would be sort of try to find these issues. And if you can't find them, you can always talk to, or you can get on Gitter or just contact one of the main contributors and ask, what are some issues that are for newcomers? Like I see you have a pretty large code base here. I don't really know where to start. And then they might point out some issues that you can work on.
Yep.
And then based off of that, you can just start working on the issues. And eventually you'll just start picking up, what to work on, and you can just start working on it at your leisure. That's the other beauty of open source, I guess, is really no like deadline or anything. It's just you sort of work on it, for fun. You're working on it because you enjoy the work that it offers you and the work that you do. So I think that's my key piece of advice is you can always contact the contributors. I think the fact that they are open source sort of means that they are open to communicating with the rest of the community itself. So there's no shame in reaching out and saying, I want to contribute. How can I contribute? They might say, oh, you can do X, Y, Z. Or they might say, oh, here's a few issues that I've opened that are pretty straightforward, and they don't involve you to be a current member of the contributing team. Mm-hmm. So that's my little 2 cents there on what people should try to do if they do want to get involved.
Okay, I'll definitely have our H2O3 repositories linked in case anyone of you wants to go ahead and check out those for contributing. Now coming to your title, which has evolved from hacker scientist to software engineer / data scientist. Now this is a very interesting intersection because these are two contrasting personalities, one which writes really good code and the other is known for reading stats papers and sitting in the middle of a GPU cluster writing bad code. Why was this intersection important to you?
Yeah, I think if you write pretty good software, like pretty good code, for example, that leads to a lot of reproducibility. So it allows people to, especially if your code's open. So what a lot of people are doing now, a lot of data scientists or people who are in machine learning, they're sort of publishing their papers, and they also have code now that goes with the papers. That's something you didn't really see in the past. You would see maybe like a paper, think about like the paper about GBM from Jerome Friedman, most likely. Maybe there wasn't, I don't know if there was a software pack at the time, but most likely there probably wasn't. Or like old papers about GLMs from like the 70s or 80s. Like there wasn't any open source software available that someone can just take a look at and see what this person did. Nowadays, I think that's more of a norm. People are doing that now, especially if papers are published to archive or something like that. And then Patrick Hall and myself and Kim Montgomery from H2O and an outside partner, we're working on a paper that's just like that. It's called, we're going to hopefully be published soon, but basically it's a paper about interpretable machine learning in Python with open source examples. Now, if you write if you write code that you can't comprehend, no one can take that code and use it. If you
Yeah,
write code that can't be compiled correctly or you need to do a lot of crazy things to make it work, people won't use it. So I think if you go about practicing both of those, so practicing, good programming and then plus data science, I think that's a powerful tool to have, and that's what I, try to achieve in my day-to-day work. I think it just leads to good science, particularly. That was sort of what that led to, and then the reason I think my title is the way it is because I do work on a little bit of both. So like some days I'll be working on maybe more of a data science problem, which might involve, writing about some method that we're working on or Jupyter Notebook or implementing some data science algorithm. But other days it might just be pure software engineering type stuff, like
okay,
working on the continuous integration or working on some improvements to the software processes we have, testing, all those type of things, which is more traditionally software engineering. So I think that's where the two overlap for me. But I think in general, I think most data scientists are probably leaning towards writing better code, which could accompany their whether they're writing a paper or work related things, and that can lead to more reproducibility of results. And based off of that, it'll just lead to better, practices of data science, I think.
definitely. Some data scientists try to get away with not so good code. I am particularly not very proud of the code that I put out, but where should we draw the line if, for example, a data science enthusiast is more focused on learning stats and the concepts around it? How much of effort should they put in learning software engineering skills, for example?
I think you should put in a lot of effort into learning software engineering skills. So you can learn the fundamentals. Yes, I definitely agree. You should definitely learn the fundamentals of statistics, mathematics, all those type of things. Those are important when it comes to reading the papers, sort of understanding why certain methods work the way they do. It gives you the necessary background. So I think those are definitely good to have. The thing is, software engineering I think takes a lot more time to sort of I don't know the correct word, maybe master or achieve the skill set needed,
Mhm.
because it takes a lot of practice. I
Yeah,
think, at least in my personal endeavor with software engineering, it takes a lot of practice. So in college, you can take a programming class, which like many people do. I did. You take the intro to class. You take the intro classes. You learn about data structures, algorithms, and those give you the necessary background to sort of put software together, piece things together. But anyone can piece things together. I
yeah,
think I think what if there's people out there who are aspiring data scientists and let's say they're in a stats or machine learning program where they're doing a little bit of programming, I think they should focus on more of the programming side, more of the application side, because that will open up your opportunities in the future. Because every data scientist should have an understanding of statistics or mathematics. That's just a
yeah.
given. That's what's going to be in their background, whether it be formally or informally, like they maybe took an online course or something, or they got a college degree in it. But the programming side, I think, is important because a lot of companies are interested in making data products, are interested in ETL processes,
Mhm.
extracting data, cleaning up the data, um, making applications with the data. A lot of that stuff involves software engineering skills. So I think you can be ahead of the curve a little bit compared to the rest of the people trying to get these type of jobs if you can, let's say, put an application together from
Yeah,
scratch. And not just an application, but maybe a pretty efficient application together from scratch. That's a pretty good thing to add to your resume, add to your GitHub profile, for example, because this showcases your ability to put together data science ideas like statistics, mathematics, with software engineering skills. And like I said earlier, those take a lot more time to put together, I think, um, um, compared to um, just learning the basics of statistics or mathematics.
yeah.
a lot of times in the field, you'll do a lot more programming than some people might like. So it's probably better to learn that initially.
You mentioned about building projects. Many people now trying to make this shift just learn through online courses, take even programming courses, and followed by data science courses. How should they find these ideas, and how should they think about what projects to build to showcase to recruiting managers or companies?
Yeah. So I think the first thing with like a data science profile is maybe you can sort of think of a problem you want to tackle first. Because a lot of times with GitHub now, I think everyone who's in the data science field should have some type of GitHub account to showcase their work. Um, or they can have a website, but the GitHub account's easier because it's
Yeah.
already set up for you. So you can set up a GitHub account. You can try to think of a problem you want to tackle, or think of a interesting data set that you want to use, and then based off of that, you can do a lot of different things to showcase your skills. So it doesn't have to be building a machine learning model per se. You can probably do a lot of great exploratory data analysis, which you see now in Kaggle, especially with Kaggle kernels, for
Yeah.
example. You see that a lot now, where it's not really about just building the best model, but people are getting credit for building interesting findings or finding certain things in the data set itself by using a lot of great EDA. So that's one thing that people can add to their resume, is sort of showing how you can explore data in a proper manner, which is what data science is for the most part. I think for the most part, data science has to do with cleaning up the data properly and also exploring the data properly. I think those are very important skills to have, and those are very important skills to showcase.
Yeah.
Because if the modeling is getting automated or getting to the point where you can churn out a lot of different models, it's not as impressive to see someone just call some model on a data set without doing anything to the data set itself. So EDA is one of the important key things I think someone should show on their resume, and then you can take many online courses about that. A good one is probably anything offered by like Coursera, things like that. Maybe MIT has a lot of free stuff from their online courses. Stanford has a lot of online courses. And another good thing is you can always look on GitHub and see what people are working on, and then sort
Yeah.
of take some inspiration from that. I mentioned Kaggle kernels earlier. That's a pretty interesting one to look at as well, because especially if you look at some of the top ones that people do, a lot of interesting results on there. And then based off of that, you can get a lot of ideas to apply to other data sets. So I think that's where people should try to focus on, the process of data science, which is a lot about dealing with data.
Yeah.
So that's where you can improve your programming skills when it comes to dealing with data. You can sort of build out ways to explore the data, find some great insights into the data, and put that into a nice, maybe GitHub project.
Yeah.
It could just be a bunch of Jupyter notebooks or something. Sort of write out what you did, and then that's something you can show someone, because that's something you actually did. It's tangible. You can take that and take it to a hiring manager and be like, this is what I worked on. What do you think of this? And you can do this for many different things. It's not the same as just, I don't think it's the same as just before, where you can just finish like a master's program and then and hope to get a job. You have to show something.
Yeah.
So in addition, that's why with like software engineering interviews, people are given like take home assignments, or they're given maybe like a whiteboard type of thing. I think the
Yeah.
same thing can happen with data science. So I know in data science interviews that there are the whiteboard interview where you're given a problem and you got to explain how you would solve it. That's great, but at the same time, there's a lot of issues with that type of interviewing process. So if you have, let's say you're just like a nervous person or something like that, and you don't do well, but you have a great profile, a great resume of projects you worked on, that can help
Yeah.
you at the end of the day. Something you worked on, something you wrote together, something you did on your own, or maybe with another person. But at the end of the day, it's something you worked on, something you came up with from scratch. It shows your ability to think analytically, critically. All these things can be showcased nowadays via the power of GitHub or Kaggle or anything like that. So I think that's where people should try to go towards, is you shouldn't think you need some formal education in this. All you need is, you just need to gain the skills of, like, let's say, efficient programming, statistics, mathematics. You need to be able to formulate problems. You need to be able to figure out how to solve these problems. And you need to showcase these problems in such a way that other people can get their hands on it. And that's just a good way to go about things nowadays, especially.
I'd also like to mention, you mentioned Kaggle kernels, which are rewarding if you're a great storyteller, and also if maybe someone might not be as skilled as you to skilled enough to write a book, but if you start blogging about your data science projects, those are also very big positive signal to hiring managers or even the community.
Yeah, definitely. I definitely agree that like writing blogs, um, maybe even yeah, writing blogs is a great way because you don't have to go through a review process of a journal or anything, and you can and like the Kaggle kernels itself are a great way to showcase your storytelling because that's what data science is. It's mostly storytelling. You're sort of with your I mean you're telling a story with the data. You're trying to figure out what this data is telling you,
Yeah,
and Kaggle kernels have opened up a lot of opportunities for people. I think GitHub's also a great way to showcase it as well. Um, and yeah, writing blogs, or I think some people even do like YouTube videos
yeah,
of how they went about solving a problem. Um, a lot of times, like a lot of the cool things is when people win Kaggle competitions and then they have a whole blog about what they did. I
yeah,
mean, that's a pretty cool thing to show someone because it's one thing to be in, let's say, like when you go to like an interview for a data science position, there's only a certain amount of time you have to get whatever you need to get out there.
yeah,
And a lot of times it's based off of the questions the other person asked. It would be really nice if you can just point to a blog that you did or point to some like notebook you made or some analysis you did and just be like, this is what I worked on. If you're interested, please take a look. I can answer any questions you have about this. I think that's a really powerful thing. Um, uh, I mean, I sort of wish I knew about this when I was applying for jobs in the beginning, but back then maybe it was a little different. This was maybe like 6 years ago, 7 years ago. Maybe people weren't doing that as much, but nowadays I think that's going to become the norm. Like people want to see what you've worked on,
yeah.
so you need to sort of put it out there. I know it's hard for some people because you might be working on projects at work that you can't share with the world, and that's totally understandable. And at that point, you should probably figure out a way to explain that to people in an efficient manner.
Mhm.
Um, but if you do have the time to do these open source type things, these open source type of analyses, I think it's very powerful in trying to find other positions if you're interested in jumping into data science.
The another point is blocking or even working on Kaggle competitions sets off these chain reactions. I've seen many competition winners or maybe even the top 10 finishers writing even research papers. People worry, like even you said, contributing to research opens many doors. So even if you produce a very novel solution that might not have won the competition, even that could also lead to very interesting research results.
Yeah, I think it can lead to interesting research. These sort of blogs that people put out and things like that. It sort of opens the door for a lot of different research, and I think the blogs itself. I mean, I find them very interesting. I think they will raise a lot of questions for a lot of people as well. Maybe they can build off of these type of blogs for maybe another competition they're in or something else they're working on. So I think
Yeah.
it's very powerful. Yeah.
Now, coming back to H2O, I'd like to understand something from you because I've only been at H2O for 3 months. But can you tell me more about the maker culture and the makers gonna make a philosophy that we follow?
Yeah, to me the maker culture I think has to do with giving people that work in the company freedom to work on problems they're interested in. So I always found that, or I've always loved that about H2O is like a lot of the problems that I've worked on here, a lot of the teams I've worked on is sort of been my own choice to a certain degree. I could I could I could say, I'm interested in working on this problem, and most of the time people were okay with it and they'd let me do it as long as it wasn't too out there. They would let you work on it. With MLI, like I was interested to work on MLI, and I've been able to stick with it for a long time. Um, so I think that's sort of the maker culture, is sort of giving the employees of the company freedom to work on what they want to work on, and I
It could
think
even be
that
drinking chai and producing podcasts for those who are curious.
exactly. I mean, I think the maker culture has to do with like a lot of people has to do with having the curiosity to go after a problem. And then if you're curious enough, that leads to some type of passion. And if you're passionate about a problem, you're going to spend a lot of time with that problem, and that sort of makes for good work. at the end of the day. Um, that's why, you know, um, I mean, it's the same concept with like, people in academics who are working on problems. I mean, those are problems they chose to work on. So
Yeah.
why not apply that to industry as well? Get the right people to work on the problems they're interested in. And then hopefully from that, you'll get a lot of great products, a lot of great output, and a lot of interesting findings. And I think that's what the maker culture has to do with specifically H2O.
Awesome. Now, you've already shared many great advices, but if you were to give any final best advice to someone who's just starting out, who's just signed up for an online course, or maybe just thinking of doing the first open source contribution?
Yeah, I think what someone should do if they're just starting out is they should take the online course or whatever they're doing and sort of document what you've been learning throughout the process. So document in the way that, it could be something as simple as, oh, I'm taking this online course on machine learning. I'll make a GitHub project that's called this online course that I'm taking, whatever it may be, like intro to machine learning or something. And then then you put down all the assignments you worked on, things like that in that project itself. And then what that catalogs, it'll have a history of your thinking process of what you've been working on. And then that's something you can put on your profile as well. Like I mentioned before, you can also work on certain data science problems you're interested in. So, get your hands on a data set you're interested in, or work on a problem you're interested in, and get the right data set to tackle that problem, and showcase your thought process through your online profile, your online presence, whether it be if you have a personal website, showcase it there. If you have a GitHub account there, Kaggle kernels, whatever you want. I think that's what people should be doing now from the beginning. And you see that in a lot of, that's how a lot of like data science boot camps work, actually.
Yeah.
If you look at things like, or if you look at the assignments they do, a lot of times it has to do with something the student came up with themselves. And that's something you could, and so they're basically going through that same process. They're saying, we're going to teach you these set of skills, but at the end, we want you to put all these skills together and make something out of it. And that's something you can do outside of a data science bootcamp, technically. I mean, you could just, like I said, it's just the science. You just formulate a problem, collect the right data you need, and then tackle that problem. And if you're able to put that together in some type of document, whether it be a blog or just some like PDF doc or just a very well annotated notebook, that's something you can show someone. So that would be my piece of advice to anyone getting into machine learning now is you sort of want to show what you know, and you want to show what you've been learning. So I think that would be my piece of advice, especially if you're coming into industry. Academics might be different. You might need to showcase like implementing an algorithm or something like that. But when it comes to industry, I think that's what people are mostly interested in is your thinking process and how you go about solving these type of problems that you might encounter. Yeah.
Awesome. Now, before we end the call, can you tell us what would be the best platforms to follow you and follow your work?
Oh, the best platforms? So you can follow me on Twitter. I usually am on there, and LinkedIn. Let me see what else. And then of course, the booklet itself, it's in its second edition, the Machine Learning Interpretability booklet from O'Reilly, and that's available through the H2O.ai website.
Okay. All of these will be linked in the description. So please don't be lazy. Scroll down and find these links if you're curious. Thank you so much, Navdeep, for joining me on the podcast. And thank you for all of your contributions to the MLI community and the open source community.
Yeah, it's great to be on here. Great to be on here. Thank you so much for having me.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.